Hi, I'm a professor of computer science at the University of California in Santa Barbara. My background is in system security. If you look at the security space, you can really break it down in two main groups. You have cryptographers that do more sort of theoretical crypto stuff, and system security people that build system to solve problems. And so I always focused on the second kind of research, trying to create system, for example, to analyze malware or to analyze malicious web pages. And this research was made available to the public because we're academics and we want people to enjoy the fruits of our research. And people liked it and find it useful. And so we received, me and my colleague, a lot of pressure to take this technology and make it available commercially. And so that's how our company, Lastline, was started, by sort of implementing in a commercial way the concepts that we developed as part of our research.
So is Lastline aimed at companies or individuals for security?
Lastline is mostly aimed at protecting large corporations. I would say medium to large corporations. What we do fundamentally, we sit on the network of these organizations and we try to understand if they're being attacked, if they've been compromised, by using a composition of various techniques that includes sandboxing, so analyzing programs and documents, but also analyzing sort of the various aspects of the network using machine learning, artificial intelligence, in order to identify anomalies and things that shouldn't be there, shouldn't happen in that network.
So did you have any mentors or people who inspired you to get into the industry?
I had several mentors. I would say that I got into security because I love the challenge, and I started doing security stuff when I was very young. I was just loved security, the concept of, from locks to networks to, hey, what's in this computer and why it works that way. And so but I did my studies in engineering, and then there was one professor that was actually in Santa Barbara that was an expert in security, and I really wanted to do a little bit of work with him. So I went to visit. Him after my PhD in '97, and I never made it back. So I stayed there, worked with him for many, many years. So I would say that definitely he's the reason why I stayed in security for so long.
So currently, what sort of cybersecurity trends are you particularly interested or worried about at the moment? I mean, what's defining trends of 2018? Would you say?
So, in terms of the threats of the things that we see in attacks, we see a lot more evasive threats. So things that try to really escape analysis. And we have seen this for a while, because as the good guys, quote unquote, develop mechanisms to protect the network, but the bad guys develop techniques to bypass these mechanisms. And these techniques oftentimes are this evasive approach where they try to look like something that is normal while instead they are not, or they try to identify if they've been watched. So when you receive, for example, a PDF document, that document might contain JavaScript code that attacks you. One way to identify that malicious code is to open the document in an environment that looks like your computer or somebody's computer, but is actually an analysis environment that looks at the document and say, hey, are you gonna attack me? Are you gonna do something bad? Now, the document could look around and say, hey, am I in the real world or am I in this simulated world? And if it's in the simulated world, start behaving like a normal document. But if it realizes that it's actually on your computer, then it will start attacking. And so this is evasion, the ability to fingerprint the environment around yourself, you being a piece of malware or a threat, and being able to have different behavior according to that. Now, this is something that's been going on for a while. What we're developing more and more, and I'm talking about the security industry, are techniques based on machine learning and artificial intelligence. And the problem there is that oftentimes these techniques do not take into account that what we're trying to learn or we're trying to model using these techniques is fighting back. So if you think about how machine learning and artificial intelligence were born, we're born to process large amounts of data and recognize, for example, images or the natural voice or text. All these subjects of analysis are not fighting back. A picture is not trying, to pretend to be a cat when it's a panda or vice versa. It's just a picture. While instead, when you apply artificial intelligence techniques to programs, so possible malware, to documents that could be malicious, these documents can fight back and can, for example, decide, hey, if you're using this particular machine learning technique, I can change these few parts and keep being bad, but I will be classified as benign. So these are the risks that I think are gonna bite us back in 2, 3, and maybe even 5 years from now.
Do you think we've got enough security professionals at the moment to sort of be on the side of the good guys, if you like? Because at the moment there seems to be a bit of difficulty recruiting enough people. Would you say that's the same in America as it is over here in the UK?
I think that this is a problem that permeates the whole security field. Creating enough people that can effectively perform security duties of any kind, it's something that has been the thorn in the side of the government, of organization, even of education. We cannot, as a university that has a strong presence in security, we cannot produce enough people because there is such a demand. So this demand is what has driven in large part the introduction of artificial intelligence in security, because many of the tasks that were carried out by humans, they couldn't scale up. We didn't have enough analysts, enough signature developers, and so forth to fulfill the demand. And so people start looking at automated techniques, machine learning techniques, AI techniques, in order to cover some of these tasks. Of course, this is not a solution. You will always need a human in the loop eventually, but you can try to optimize that time as much as possible. And in fact, one of the trends in the industry is really a focus on the sort of like we call the first level analyst. So the guy that is looking, or the woman who is looking at a screen, looking for the first evidence of a possible problem in a network. Now that person has to take that event and decide what to do with it. So sometimes without a lot of contextual knowledge, deciding if this is a super serious breach and something has to be done immediately, pull the plug or something like that, or it's just somebody who downloaded some spyware that will just monitor his URLs. Making that decision is very hard for somebody who's not very experienced. So these techniques that are developed by the industry and also by our company try to really provide to that person the best possible view so that the decision can be made in a split second, and not by having to do the Sherlock Holmes of the situation and spend hours trying to identify what the real problem is.
At one point, mobile security seemed to be lagging behind some more general security. Do you think it's caught up now? Where are we with mobile security?
I think mobile security has not caught up with the way in which we do security for other systems. And I think that one of the points is that especially the Android ecosystem is going a little bit through what the old Windows XP, Windows 7 was going on at the time. And that is, there is a core operating system that has maybe good security mechanisms, but then it has to be run on a number of different platforms. Platform being different types of phones from different manufacturers, and each of these phones has a number of chips, little pieces of hardware that handle, for example, the gyroscope or the broadband communication or the audio or the video. And for each of these pieces of hardware, they are different from every phone. You need a little driver. Now, the core system, the Android OS, might be well designed and secure, but oftentimes these drivers are developed under a lot of market pressure by developers that are not experts in security. And so actually what we have found is that a lot of vulnerabilities are not in the core system, but they are in the driver. The problem is that the driver runs like the core system. And so compromising a driver might lead to the complete compromise of the phone in a way that it was similar to what was happening with Windows. And now things have changed. There are different ways to load, kernel drivers. So there is an enhancement of the protection. But for phones, this is still a problem.
You seem to be involved with hackathons and hacking contests. Why do you think those are important?
I think that hacking contests are a great way to attract talent, because you have to do very sophisticated security analysis and operations under time pressure and in a fun environment. And people are drawn to this competition and end up putting 10 times the effort they would make in if I would just give, for example, a class assignment. Class assignments are, I have to do this class assignment, I will do it. And the moment you say, okay, you five have to hack into each other's computer, they will go nuts. And the important thing is to make the experience controlled, of course, but also educational, so that they understand, while performing all these hacks, the attacks and defense, understanding the basic mechanisms that are, the underpinnings of how you develop secure systems.
National Cyber Security Centre recently warned that the threats of cyber attacks on Britain's critical national security infrastructure from hostile states like Russia and China, North Korea, has soared over the last couple of years. Why do you think that there's more nation-on-nation attacks going on at the moment? Do you think that it's just the nature of the game? As the stakes seem to get higher, they're going to start investing more resources into that sort of attack?
I think that nations, especially certain nations, are making major investment in their cyber attacking capabilities. This is because it's something that can provide an enormous amount of benefit with very little engagement, and very little cost as well. You don't have to be present there in order to steal some state secrets. You don't have to break into a safe. You don't have to do a lot of things that would get you caught, that would get you identified. And therefore, it makes sense from a strategic point of view to invest in that. So it becomes the classical arms race. As more nation states develop more security attacks, more the nations who are the targets of these attacks will have to develop better security measures to block these attacks and make them ineffective in some way.
As a kind of outsider looking in, do you think Brexit is going to affect cyber security issues in this country? Or?
It's a good question. I don't know if Brexit is going to affect cybersecurity. This is more, I would say that mostly it will not affect the security of the nation infrastructure. You could have some fringe people deciding that they want to attack the infrastructure because of Brexit. It seems to me a little bit far-fetched. I think that the problem is going to be more in the human aspect. So Brexit might make it more difficult to recruit good security people from places that are in the EU, and therefore there will be an even bigger scarcity of security talent to protect British networks from attacks.
You were sort of saying about AI, and it's going to kind of come and bite us on the butt, if you like, in a few years' time. Are the good guys drawing level with the bad guys at the moment, or are we kind of losing the battle?
I think that the bad guys will not win the battle. I think that good guys can win the battle and will win the battle, in my opinion. But we need to be able to use machine learning in an effective way. There is this concept of adversarial machine learning, where you have to learn and apply a learning model in an environment that is fighting back. It's our responsibility as good cybersecurity researchers to develop techniques that are resilient to this kind of attack. So I think that we're going to lose the battle if we take the techniques that we develop for image recognition and text recognition and we apply those techniques in a naive way to this new domain. But if we are very well aware that the domain that we're trying to analyze is fighting back, then we got a chance to develop novel techniques that are specific for the security domain that can be effective at stopping these criminals.
So what's next for Professor Vigna?
Yeah, what's next? Well, I always wear two hats. So I'm a professor of computer science. So I continue to do my research with my research group, which is very big. We have a lot of students, a lot of interns, and I co-direct the lab with my colleague Chris Krugel. And with Chris Krugel and another professor, Engin Kurda, I also founded Lastline, our company. And so in both my company and UCSB, I see great opportunities to do something novel. In the research, I'm often inspired by what I see in the real world when I have to wear my hat of the CTO of the company, and vice versa when I'm doing, my CTO duties. I look at what happens in the security field, in the research field, because I think that only by continuously innovating technology, you can keep up with the ever-changing threat.